Good afternoon. Thank you so much for the generous introduction. I really appreciate it. Uh, I felt a little embarrassed, but that's okay. Um, yeah, so it's really great to be here in Cape Town because this is not the first time that I'm here. First time I came to Cape Town was in 1998 when I was still a grad student to work on the Langabambe collection. Because what I was working on was similar age as Langabambe, even though the fossils that I concentrated were from Ethiopia. And then I came back a few times to either study specific taxa, like, taxon like suids, or for the Langevandvik workshop at some point, and then I came back. So basically, it feels like home. So I'm not new to Cape Town, and I'm always happy to be here. So today, what I'm going to do is, since this is the year 2024, and it's the 100th anniversary of the discovery of the Taung child, and also the 50th anniversary of the discovery of the partial skeleton known as Lucy from the Afar region of Ethiopia. Now, there are so many fossils in paleoanthropology from various countries, Ethiopia, Kenya, Tanzania, South Africa, but these two specimens are really iconic specimens in paleoanthropology. They've changed the way we understand our origins in a lot of ways. And some of them, like Taung, is actually the specimen that actually showed for the first time that Africa is the origin of humanity. And it really changed how people, particularly Europeans at that time, thought about our origins. Because everything in the old days was so Eurocentric that they never expected Africa to be the home of our origins. So basically, to start my talk, let me just introduce a couple things. The first one, introducing the two specimens that are that I just mentioned, the Taung child, just as a background information. So this was found in 1924 at Taung and introduced to the world in 1925 by Raymond Dart. And this is the holotype or the reference type specimen of Australopithecus africanus. Apologies for the typo here. It's type specimen, not type species. This is also the first fossil evidence to indicate that Africa is the birthplace of humanity, and also proved that Charles Darwin was right. I'll get back to that a little later. The second specimen, Lucy, or known as Dinkanesh in its Ethiopian name, this was found in 1974 at Hadar in Ethiopia. And this was also the first specimen that showed that bipedality is older than 3 million years. Because at that time, most of the South African specimens that we knew of were considered to be younger than 3 million years. So the antiquity of bipedality was confirmed by the discovery of Lucy. And basically, Lucy's discovery kind of redefined the course of human evolution in terms of how we interpret the fossil record that we had at that time. But most importantly, Lucy was also the one that inspired extensive survey and exploration for new sites, particularly in Eastern Africa. So this is like a background information that I wanted to give you about those two specimens. Now, speaking of human evolution, before the 1800s, basically people are really interested and curious about human origins. Where did we come from, right? And you can talk to people in different societies, different cultures, and for thousands of years, they've been building their own narratives and stories about our origins. And especially in Europe, prior to the 1800s, the interpretation of human origins and evolution was pretty much around what they called at that time the Great Chain of Being, which kind of connects or links God, angels, humans, animals, plants, and minerals, right? So that's how it was interpreted, like God being on top. But in the 1800s, a lot of new ideas started developing. And this culminated in Charles Darwin's publication in 1959 of the book titled On the Origin of Species. And then about 12 years later, he wrote another book in 1871, which was titled The Descent of Man. Now, in The Descent of Man was when he talked about human evolution for the first time. Actually, in his first book, he didn't talk about evolution at all. All he said was natural selection is the driving force of evolution. But basically, he avoided mentioning human origins, human evolution, or anything like that. It was only in 1871, in The Descent of Man, that he actually talked about human evolution. And basically, Darwin knew about the similarities between humans and chimpanzees and gorillas, more so than humans being more like the orangutans, which are the other apes. So basically, his hypothesis was that since we're more closely related, we look more like chimpanzees, the common ancestor that apes and humans shared must have lived in Africa. But of course, his contemporaries at that time laughed at him, right? How can we have our origins in Africa? There is no way it could be Africa. So basically, one of the reasons why the Taung child is really important is because it was the specimen that brought the attention of anthropologists to Africa. And Raymond Dart, who described, he did not find it, but he described the Taung child, was the first person to actually introduce the specimen to the world. The reaction from the European anthropologists was not great. They reacted in the same way as they reacted when Charles Darwin suggested that our origin was Africa. But clearly, for Darwin, when Raymond Dart published Australopithecus africanus using the Taung child as the holotype specimen, this is what he said. For calling it Australopithecus africanus, he said it's in commemoration, first, of the extreme southern and unexpected horizon of its discovery, and secondly, of the continent in which so many new and important discoveries connected with the early history of man have recently been made, thus vindicating the Darwinian claim that Africa would prove to be the cradle of mankind. So this was really a major turning point for the European anthropologists. Now, the reaction that they, gave to Raymond Dart was like, you must be kidding us. There's no way that humans could have evolved and originated in Africa. It took 35 to 40 years before everybody accepted that this was actually true, that humans originated in Africa. And this is because of the work of people like Robert Broom, who's been conducting a lot of research at Sterkfontein, Makapanskat, and also Kromdraai, and all other places. And all of the discoveries that were coming out of South Africa, particularly from Sterkfontein and Makapanskat, some of which are shown here, is what confirmed that Dart was right. This is the earliest human ancestor that we can talk about, and we're talking about all the discoveries by Robert Broom until 1947, 1949, which kind of sealed that idea that Australopithecus africanus is actually the ancestor of humans. So the discoveries in South Africa didn't stop with Australopithecus africanus. Robert Broom continued his work in the various cave sites, such as Swartkrans and Kromdraai. In addition to africanus, he also named Paranthropus robustus. At that time, they called it Australopithecus robustus, but he also had another species that he named from this cave sites. So basically, this is what really sealed the idea of Africa being the origin of humanity. So the discoveries from South Africa did not stop here. I mean, even recently, we've seen a lot of discoveries, which includes Littlefoot. And I'm sure you know why it's called Littlefoot. I'm not going to get into that, but I had the opportunity to come, I think this was in 2017, and Ron Clark was really proud to show me the skull while they were still preparing it. This was in his workshop in Sterkfontein. So basically, that's something that can be mentioned as recent discovery. But in addition to that, we have Australopithecus sediba, and also Homo naledi, which National Geographic reconstruction kind of show you what Homo naledi might have looked like. So when you look at the record that we have from South Africa, there is plenty. And because the initial discoveries were from here, from South Africa, all of the research came to Africa because of the discoveries in South Africa, right? That is why we have South African sites as the cradle, right? So basically, it is one of the areas that we have a lot of attraction for human origins research. But then in the 1950s, research kind of started in Eastern Africa. This is because of the work of the Leakey family, right? And Mary Leakey and Louis Leakey luckily found a cranium from Olduvai that they called Zinj. This was 1959. They've been working at Olduvai Gorge for more than 20, 30 years before that, but they never found any human remains. This was the big discovery they made in 1959, and this is basically what triggered interest in further surveying, not only in Tanzania, but also in Kenya, in the Omo Basin. And that is pretty much what sealed that Eastern Africa was going to be really, really important in human origins research. So basically, when you see the paleoanthropological sites in Africa, you see concentration in Southern Africa and then Eastern Africa. Those are the two major areas where we have a lot of the fossil evidence to tell us about our evolutionary history. And there are so many sites. South African cave sites are the first known hominin-bearing sites because we go back to 1924. Most of the Eastern African sites, discoveries from Eastern Africa started about 1950s. But clearly, all of this work that has been done for the last 100 years kind of tells you how many sites there are in Africa. I mean, there is no better evidence than what you're seeing here to tell you that Africa is actually the cradle of mankind. So basically, once the work started in Eastern Africa, particularly in the areas that we call the East African Rift System, since the 1960s, so many sites have been discovered from those localities. But one of them, which kind of changed a lot of things in how we understand human evolution, was this specimen, this partial skeleton nicknamed Lucy from the Afar region of Ethiopia. Lucy was also instrumental in the naming of Australopithecus afarensis 4 years later in 1978. And that species, because it was older than 3 million years, it became the base hominin that have given rise to everything else that came after after 3 million years ago, including the South African hominids such as Australopithecus africanus and also Paranthropus robustus. So one of the other significance of Lucy is that she inspired extensive survey and exploration in Eastern Africa, resulting in the recovery of all this new numerous early human ancestor species that I will show you in a bit. But clearly, this is about Ethiopia, but there were also discoveries from Kenya. Now, from Kenya, we have at least 3 species, some of which are only known from Kenya, others also known from Ethiopia and Tanzania. Ornithogenensis, as a matter of fact, is one of the earliest human ancestors that we have, from about 6 million years ago. Australopithecus anamensis from about 4.2 to 3.9 million years ago. And they also have something called Kenanthropus palladius from about 3.5 to 3.3 million years ago. When we look at the evidence from Tanzania since 1959 with the discovery of Zinj, which is now known as Paranthropus boisei, they have found so many things, including the lithoid footprints that are 3.6 million years old. Basically, those footprints showed that humans were walking on 2 legs like the way we do as early as 3.6 million years ago. So that was a good evidence for the origin of bipedality and stood as the earliest evidence at that time when they were found. But from Tanzania, they also have the earliest representative of our own genus, Homo habilis, right? And then, of course, Paranthropus boisei, which you're seeing here. There are discoveries from Central Africa. Now, a lot of these hominids that I showed you were like from the eastern side of the East African Rift System. And this was really a surprise when hominids were found outside the East African Rift System. And it happens that it is actually one of the oldest human ancestors that we have by the name Sahelanthropus chadensis at 6 to 7 million years ago. They also have another species known as Australopithecus parel-ghazali from 3.5 to 3 million years, a little controversial in terms of its validity. Some people think that it's probably Australopithecus afarensis, but the discoverers have tried to show that this is a different species, a species different from Australopithecus afarensis. Now, going to Ethiopia, because Ethiopia is situated in this part of the East African Rift where it's the widest, and there is a deep cut in the rift system where it has exposed almost 1 kilometer thick sediments that have been buried for the last 6 million years. And because of that, there has been a lot of discoveries from Ethiopia. And this is just to show you like the distribution of this hominids, but mainly from the Afar Rift of Ethiopia. And what you're seeing here is there are at least 13 species known from Ethiopian sites. And we have some species that are only known from Ethiopia, at least 4 of them. 4 species are known only from Ethiopia. Some of them are actually, except for those 2, these are like all found from the Afar region of Ethiopia. And those 2, like the Paranthropus species, are known from southern Ethiopia, from the Omo Basin. So basically, when you look at this record, what we have from Ethiopia since the first discoveries in the 1960s is something that kind of covers the last 6 million years of our evolutionary history. This pretty much shows you like all the species that have been found from the Afar region of Ethiopia. Now, to just give you a little bit of a detail about each of those species, the oldest one that we have from Ethiopia is Ardipithecus kadaba from 6.3 to 5.2 million years ago. And this is really one of the earliest human ancestors, in addition to the Ororhyntogenensis that I showed you earlier from Kenya, and also Sahelanthropus chadensis from Chad. Then we have this partial skeleton at 4.4 million years ago from the Middle Awash study area, where Dr. Brahane is one of the PIs of the project for the last almost 50 years, right? No, I'm not trying to make you old, but 43, let's say. So this is one of the most exciting and intriguing discoveries from the Afar Rift, because this is at 4.4, when you have a species that is related to humans but had opposable big toe, like apes, then you realize that we haven't abandoned opposable big toe until later. Some of these relatives had kept that opposable big toe, and that was a big surprise for the paleoanthropological community. And then you have Australopithecus afarensis from Hadar, and it's also found from Dikika, from Middle Awash, and also from Woranzimile, which is what I'm going to talk about in a bit. Then at 2.8 million years ago, we have the earliest representative of the genus Homo. It hasn't been named to a species yet, but this jaw has been assigned from Lady Gararo, has been assigned to our own genus. So basically, this is the earliest evidence for the presence of Homo as early as 2.8 million years ago. Technologically, we also have the earliest stone tools, among the earliest stone tools, I should say, from about 2.6 million years ago. These are from a site called Gona, where an Ethiopian archaeologist have been working at for the last 25 years now, and he's documented this as the earliest stone tools from Ethiopia. So basically, most of the fossils that I showed you were found in this yellow rectangular area, major sites being Middle Awash, which is the site that has the deepest record of our evolutionary history. But we have like additional evidence from Dikika, from Hadar, from Lady Gararo, and also from Gona, right? And then what you see on top, Woranzimile, is relatively a new site that I've been working at for the last almost 20 years now. Speaking of 43, now it's 20, catching up. So Woranzamile is relatively new, 20 years old, but this was also a site that has been producing a lot of surprising specimens and basically giving us like new clues in terms of how we understood our past, particularly from what we call mid-Pliocene between 3 and 4 million years ago. Now, I'm not going to go through all of the discoveries from Woranzamile, but I'm going to highlight some of the most important specimens that have made a difference in terms of how we understand our evolutionary history. And these are discoveries that started in 2005, although published in 2009. We have these 4 specimens that I'm going to talk about: KSDVP11, Kadanumu, nicknamed Kadanumu, BRTVP273, the Burtele foot, some remains of Australopithecus deiremida, which is a new species that we named from the site, and also a cranium of a known species, Australopithecus anamensis, from 3.8 million years ago. So these are all important specimens that all of them were published in Nature. Now, especially the cranium that was published in 2 articles in Nature, and this is one of the specimens that actually earned me a good accolade from Nature in 2019. I was one of Nature's 10 people who mattered in science in that year, which was really great. But then, so basically that cranium became really significant specimen, and I'll explain why that was really the case. So Kadanumu, the Australopithecus afarensis partial skeleton we found from the site, is about 3.6 million years old. It's 400,000 years older than Lucy, but it is within that species. It's within the species of Australopithecus afarensis. What really makes it significant is, one, Lucy was 3.5 feet tall. She was about 1 meter and 20 centimeters, 30 centimeters. And the idea when she was found was that these early human ancestors are small, right? But then a year after she was discovered, there was this discovery of what they called the first family, where we had 17 or 18 individuals from a small area. And they realized that some of these individuals were like 5'5" or 5'2" or 5'1". So there were like a lot of variation in terms of size between the members of Australopithecus afarensis species. But this one was another big guy. So basically what it showed was, even as early as 3.6 million years ago, these early human ancestors were not short, were not small. They were like tall and well built in terms of their physique. So it's another evidence to actually understand what the rib cage looked like, because there were also a lot of disagreements in terms of what the rib cage looked like. Because we have some complete ribs associated with the specimen, we were able to actually reconstruct what the shape of the rib cage might have looked like, which in the old days people thought, well, early human ancestors had a rib cage that looks more like a chimpanzee, like a funnel-shaped. But with this reconstruction, what we realized is it's not barrel-shaped like modern humans, but somewhere in between. Right? So basically, that's additional information that we've learned from this partial skeleton. The next one is a species known as Australopithecus deiremida that we named from Woranzamile. And basically, this species kind of indicated that Lucy's species was not living alone. There were other related species living at the same time. Now, today, we are the only species living on Earth. But in the past, there were multiple related hominid species living at the same time, and sometimes in close geographic proximity, like what we see with Australopithecus deiremida. Lucy's species, Australopithecus afarensis, was living 3 miles away from this species at the same time. So basically, that's some new information that we have gotten from finding discoveries like Australopithecus deiremida, and also the Chadian discovery of Australopithecus paralgazali, which people also argued that species lived at the same time as Australopithecus afarensis. There is another species from Kenya, Kenyanthropus pladiops, which is also argued to have lived at the same time as Lucy's species, Australopithecus afarensis. So this is all new information because of these new discoveries. Because of continued survey and exploration, we're getting more information about our evolutionary past. But interestingly, also from around Zamile, we found a foot that had opposable big toe. And this is only 3.4 million years old. Now, remember when I showed the Ardipithecus partial skeleton at 4.4, it had opposable big toe. But then at 3.4, a million years later, there is still a species that has retained that opposable big toe. Now, you ask yourself, like, why did they retain opposable big toe, like that's something that looks like a hand, when there are other hominin species walking on two legs like the way we do? Of course, there is advantage to keeping that opposable big toe as well, because that helps them exploit even additional resources from trees. They can climb up trees really easily. So it's not like this early human ancestors entirely abandoned life on the trees. They were probably climbing up trees better than we do today. But clearly, maintaining that helps them secure more resources, more dietary resources. So it's not really something that you would assume, oh, this could be the ancestor of our genus Homo. But it just tells you like how these early human ancestors were adapting to their environment by the skeletal modifications that they have to undergo through like millions of years. And the last one that I want to talk about is this partial cranium from Moranzamile assigned to Australopithecus anamensis. This is dated to between 3.8 and 3.7 million years ago. Now, the species Australopithecus anamensis has been known from both Kenya and Ethiopia. And the age range that we had for that species was between 4.2 and 3.9 million years ago. Now, that species is considered to be the ancestor of Lucy's species, Australopithecus afarensis. But in terms of when this species lived, scientists have thought that it went extinct at around 3.9 and gave rise to Australopithecus afarensis, Lucy's species. Now, the discovery of this at 3.8 million years ago and assigning it to Australopithecus anamensis means that the last appearance date of the species was not 3.9, it was 3.8. Which means if Australopithecus afarensis started at 3.9, then the potential ancestor and its descendant must have overlapped in time, right? So basically, what you see is, only if this can work. Okay, it didn't work. Okay, there you go. It might work. So basically, it's not going to work. It's going to work. Okay. So there was a little animation here. So basically, what was here was, so anamensis previously was thought to have ended at about 3.9, and now this and that overlap for about 100,000 years. So there was an overlap that was supposed to show, but unfortunately it did not. So basically, that's the overlap between an ancestor and a descendant species. So how did they coexist? Like ancestor and descendant. Of course, it's not new. People live with their kids. People, grandparents live with their kids and so forth. So there's always overlap between generations, right? So basically, the one thing that you can assume is that they were probably not overlapping in space so that they can exclude competitive competition of any sort for resources. So basically, how does this happen is the key question. Usually, speciation happens when a small population, a small part of a population isolates itself and undergoes its own evolutionary path, right? While the ancestor is still maintaining what it had from before, right? So usually this is what we call allopatric speciation, like people, populations, small populations isolate themselves from the main population and undergo some evolutionary changes. So this is really what we saw as early as 3.8 or 3.9 million years ago. So all of these discoveries that I have mentioned so far, they come from Africa, right? And if you go back 100 years toward the time of the Taung child, or even the time of like people like Robert Broom, the phylogeny of early human ancestors was very simple. right? It was simply Australopithecus afarensis being the oldest at that time, at about 2.5 million years ago. It gave rise to everything, the Australopithecus robustus lineage and the Homo lineage. Very simple, right? One ancestor gave rise to two lineages that you're seeing here. And even in the 1980s, this hasn't changed much. Australopithecus was added, then Africanus was the only ancestor to have given rise to the South African hominin, Australopithecus robustus. But see how they put Australopithecus afarensis at the base now, because it was older than Australopithecus africanus. So it must have been the ancestor of all the hominid species that came later, including the Homo lineage and also the Australopithecus africanus and Australopithecus robustus lineages. So basically, you have one ancestor that gave rise to everything else. Now, in the 21st century, we have more than 22 species known in the fossil record. Now, this kind of complicates figuring out like what the relationships are. It was easy like 50 years ago or 60 years ago when we had only 5 species in the family tree. But now we have 20 some odd species recognized in the fossil record. And a lot of them actually show you like how different species overlapped in time. Not only once, but many times, even as recently as 100,000, 200,000 years ago, right? So all of these overlaps that you can see, multiple species living at the same time. And the key question is, how do we figure out like which one of these lineages give rise to our own species, to our own genus, right? So that's the big challenge that we have come up with by finding more species and more fossils. But clearly, that's the state of knowledge that we have, which of these species give rise to our genus. And that's why the time period between 3 and 2.5 million years ago is really critical, because that's when our genus appears for the first time. So going back a little bit to 3.1, 3.2 million years ago is really what will help us figure out that issue. But in the end, I think when we think about all of these, there are only a couple that are not known from Africa. Neanderthals. And there's also Homo floresiensis. There are now a couple other species that have been named, but we're still talking about their validity. But clearly, all of this evidence is from Africa, right? So basically, when you look at like why do we say Africa is the cradle of humanity? This is based on the evidence not just from Ethiopia, not just from Kenya or Tanzania or South Africa. This is the evidence from Africa. That's how we view like our evolutionary history. And when you look at this slide, you can clearly understand what I'm talking about, right? Because none of these countries with fossils have the whole history of our evolutionary history. It is the combination from all of these sites, right? So this is basically what we have from South Africa, and then you add the evidence from Kenya. It's a little bit more complete. Then you add the one from Ethiopia. This is what really makes Africa like the roots, the cradle of humanity. And you have to combine all of this data to have a better picture of where we came from. So Africa as a cradle has been recognized. I don't think there is any doubt. And there is no way that we can actually pinpoint this is where evolution happened. It happened in a lot of places in Africa too, especially with the origin of modern humans. Modern humans have been, mixing, like populations have been mixing for hundreds of thousands of years, only to leave Africa the way they look today about 45,000 years ago, right? But they've been going in and out like for millennia, like at least 120, 130,000 years ago. So basically, this gives you the picture in terms of when we say Africa is the cradle of humanity, that's the evidence that you can see from Africa. Now, we know a lot more about our evolutionary history today than we knew 50 years ago. or 40 years ago. And this is not just because of the fossil discoveries. There has been a lot of advances in genetics, in the way we analyze specimens, in the way we study morphology. All of this have improved our knowledge of our origins. And one example is when you think about advances in genetics that have been made in the last 50 years, we can now look into how living humans or living populations are related to one another and how far back that relationship goes. We can see genetic distances and similarities, and we can reconstruct people's movements from place to place. And in the old days, Neanderthals were totally like the side branches. Nobody thought that Neanderthals were related to modern humans. But now, from advances that we've made in genetics, we know that some populations in the world have 4 to 6% of their genes similar to the Neanderthals. And also, we can look from genetics at like how many times modern humans have left Africa, because that they look at genetic distances, movements, admixture, all of that adds up to tell us in terms of like migration phases in our evolutionary history. So there is a lot of development that have been made because of these advances in genetics. The other advance that we've made is advances in analytical methods. 3D imaging, modeling, quantitative methods, and geospatial sciences, which actually helps us a lot in terms of finding new sites, right? But especially with 3D imaging, it has revolutionized how we understand morphology, even to the extent of looking into the brain anatomy of these early human ancestors, how everything was compartmentalized. That's something that we never thought we would have done, like, 30, 40 years ago, right? So every bit of advance that we make in analytical methods also helps us better understand our evolutionary history. Now, the last one that is really very interesting to discuss as Africans talking about human origins in Africa is how much are African scholars involved in this human origins research that we're all interested in, right? And this is just to show you, like, this is 1974, the bottom picture, when Lucy was found. Lucy was excavated. Now look at all these faces. The ones that look more like me are the ones that were like daily laborers or, antiquities officers. All the research was done by these people that you see here. And that's been the trend until recent times, okay? So basically, only in the last 20 years or so, especially in the case of Ethiopia, in the last 20 or 25 years, is when you start seeing actually Ethiopians getting involved in scientific research, in human origins research, and contributing in a meaningful way, right? But I wish I had as much data that I have for Ethiopia for like Kenya and other places, or Tanzania and South Africa. But the Ethiopian example that I'm going to show you is like encouraging, but not enough. But that's something that I think we should all think about doing in all other countries with paleoanthropological resources. So in Ethiopia, since the 1980s, we've seen a lot of impactful scientists, like Brahani, who's sitting here, Zarasanai, and other people, archaeologists. And these people are the people that are making a difference in terms of how we study human origins. And this is what we would like to see happening for every African country with paleoanthropological resources. We can make it happen. But this is something that we have to really seriously consider in terms of like, how do we develop infrastructure in countries like, Ethiopia, Kenya, Tanzania, South Africa? How do we recruit potential students to be paleoanthropologists, archaeologists, right? So it's becoming like something that is like responsibility to, especially for those of us who've made it. And the next generation is what we have to start thinking about, not just understanding our evolutionary history, but to make sure that Africans are actively participating in paleoanthropological research. And these are the people, I mean, who've been publishing very impactful papers in various journals, like high-profile journals. And each of these papers, you will see have an Ethiopian scientist as a co-author. And these are people that I know have contributed in a meaningful way, not just their names being added to publications, which is what you would see sometimes, which is not something that we should encourage. So for the next generation, we're also thinking about, like, training more graduate students. These are a few of the ones that I was able to find names of and photographs of, but there are many more graduate students who are currently pursuing their PhD in the US or in Europe. Also, there are some students in South Africa that they work with Becky, and you have UCT, at UCT you have Ethiopian students, right? Yeah, that's very encouraging, especially when Africans are trained in African institutions as well. So basically, this is what we're seeing now, but this trend has to be in every African country with paleoanthropological resources. Now, this might be so impressive, but given what we have in terms of the resources, this is just the tip of the iceberg. We have to do more. We have to make sure that there are many more African scholars trained to study the resources that are coming out of their own continent. That's the bottom line. So, having said that, I just want to finish my talk by mentioning a few points here. And the first one is, clearly, all of the evidence that I showed you so far, it tells us that all living humans trace their origin back to Africa, regardless of their skin color, regardless of where they live today. That is what we've learned from all the fossil evidence that we've collected in the last 100 years since the discovery of Taung. We also have the African hominid fossil record, which informs us that more than 20 early human ancestors lived on this continent for the last 6 million years. That is many, many, many species that lived in Africa, and you can imagine how conducive it was for our evolutionary history and our evolution. And also, this is the last point that I mentioned, the demography of human origins researchers has substantially changed in the last few decades, but there is still more to be done, right? And we need to encourage our students, our local African students, to be active participants in paleoanthropology and do whatever we can as senior scientists to help them make it to the next stage. And this is something that we all have to really, really think about seriously. And that's all I have. Thank you so much.